Hello everyone. I'll be talking on custom SLOs for all. Manage your business with your own metrics. My name is Prathamesh Sonpatki. I work at Last9, where we are building the reliability platform, making it easy for engineering and DevOps teams to gain visibility, adopt SLOs, and ship reliable software. Generally, when we talk about SLOs, we talk about error ratio, latency, and throughput. These indicators are closely tied with traffic-based systems, where there is a notion of a request. A request is a single operation on a component that either succeeds or fails in generic terms. For some sources, this information might not be available. And in some cases, we may want to define SLOs on strictly business metrics where request is not even applicable. For example, for managed Kafka, an SRE managing the managed Kafka worries more about the lag, that it doesn't go beyond a known value and does not start affecting the consumers. A person managing a background queue service cares more about turnaround time than anything else. Things get even murky when business metrics come into the picture. A person managing a payment subscription service at a large streaming company cares more about the ratio of initiated requests versus failed requests to make sure that the percentage failures remain under certain limit and doesn't go haywire. Examples are endless. Let's look at the services from a new lens. Services can be customer facing, like an HTTP or gRPC workloads, where the caller expects an immediate response. They can be stateful, like a database as well. It is common to confuse database not as a service, but if you look at RDS, the relational database itself, name itself has as a service in its name. There can be asynchronous services as well, like the one that does not respond with the request result immediately. Instead, it queues it to be processed later. There can be operational services, usually internal to the organization for running the jobs such as reconciliation, infrastructure bring up, and tear down. One should be able to set health objectives depending on the type of service and depending on the health indicator that they want to measure the health of the service on. SLOs are nothing but ultimately a formula which defines an objective over a period of time against an health indicator. We can't rely just on error budgets or fixed set of SLIs in all the cases. Instead, let's turn this around and start talking about window SLOs, which can allow us to define SLOs on any metric, even the business or product metrics that we want to set SLOs on. Window-based SLO is a ratio of good time intervals versus total time intervals. Good here is defined by a goodness criteria. So in case of request-based SLO, while we are talking about the total number of requests versus failed requests, in case of window SLOs, we will talk about what is my goodness criteria for a small amount of window of my total window. For example, if I have a window of total 1 day, and if I divide it into smaller windows of 15 minutes each, what does my each window turns out to be? A good or a bad window can determine the SLO calculation. And because this goodness criteria is completely in my hands, I can take care of it defining for any metric that I want to use in my SLO calculation. While compliance window, target, length of sub-window can be independently decided, goodness criteria can be unique to the service that I'm operating on. It is defined on the SLI or the service level indicator. It defines whether the sub-window was good or not. And this can only be decided by something which either returns a true or false. Because if there is an in-between answer, we don't know whether the window was good or bad. It can be in an unknown state. So we have to see if we can consider something which can give us a Boolean value. And that can be done using a mathematical expression that evaluates to a Boolean. And pretty much solve the problem of defining the goodness criteria. The question remains though that, for example, in this case, I have used x greater than 85. 85 can be the value that I want to be above a certain limit. But what is Mr. X in this expression? It can be daily active users, failed tenants, pod availability, or payments failed ratio. It is nothing but just a service level indicator. Depends on what service I am measuring the objective on. While metrics are quantifiable measurements that present health, performance, and quality-related information of a service level indicator is derived from one or more metrics and indicates performance that a service is delivering at a given time. Obviously, there can be one or more SLIs for a given service. So in a nutshell, we can think about SLIs as a function that takes one or more metrics and returns a value by operating on those metrics. Example of expression can be like this, where I define the Kubernetes virtual cluster availability in terms of unscheduled pods and desired pods. Whenever I'm defining any expression, what I have to take care of is the expression is correct, it is semantically valid, and it is not resulting into certain corner cases, such as when the denominator or numerators are zero, because that will affect my SLO calculation. Because if something like a wrong value comes out from the expression, it may affect my goodness criteria. Let's talk about where do these metrics come from, because once we have the metrics, only then we will be able to define the SLIs. There should be no constraint really on the metrics, because if we start putting the constraint, we go away from our initial problem of being able to define SLO on anything and everywhere. Even the business metrics can be emitted in certain cases by the application and the service owner, which we should have access to. The system where we will get the metrics, it should also provide us some sort of aggregation so that we can define the metrics in terms of that if required. Let's turn to our trusted friend, Prometheus. Most of the people are already aware of Prometheus and using some sort of PromQL in their daily day-to-day life when they're observing the systems. If we can just use PromQL to define our metrics, we can solve the problem of bring your own metrics part, because then we can combine different metrics and label sets that are already present in Prometheus and create hybrid metrics, derived metrics on top of that. The PromQLs can be constructed in different ways so that the same data can be seen from different lenses as per the service owner's requirements. This also is a tool that is heavily used in the industry. So we don't have to worry about learning about a new tool, because we are leveraging on what we already have in terms of the tool, which gives us the power to define the metric definitions. So, like to summarize and connect the dots, bring your own metrics, connect them using PromQL, define the metric queries using PromQL, define the SLI expression on top of that. This can be just a mathematical expression. There is no notion of data source involved here. While defining the SLI expression, the only thing that we have to worry is it should be semantically correct. And it can run on a data frame pipeline, like Python has data frame pipeline, Golang has data frame pipeline. So it can run on top of that. Set goodness criteria that will allow us to define whether to say that whether the sub window was good or not. Again, this can also run on a data frame pipeline. And then using all of this, combining it with the SLI compliance target compliance window, we can define SLOs for any business metric, any product metric, any other metric that we want, based on the services type and the health indicator that we want to measure the services health on. That's it. Thank you.